This is Dr. S.P. Arsa from Mechanical and Engineering Department, IIT Roorkee. In the course of vibration control, we know that we adopted the two main methodology in this. One is the passive vibration control and second is the active vibration control. Till now we discussed about the passive vibration control, in which the basics, that how we can add the features like the spring, the mass or the damper straightway on the source or on the receiver or on the propagation path to suppress or to control the vibration amplitude. And also whatever the energy which is being there due to the excitation feature, we can dissipate, we can straightway transfer and convert into the heat by various ways. We discussed about how we can design the isolator based on the amplitude, based on the frequency of the vibration excitation, and also you see here the two main properties which we adopted in designing a perfect way of the isolator, like the impedance and the mobility. And based on these two, we calculate the insertion losses, and then you see here there is a straight designing feature or the procedure for the passive vibration control. And also we have seen that the individual impact of the spring or the mass or even you see like the damping can have the individual feature and can be added straightway in suppression of the low frequency, high frequency or the resonant condition of the vibration. And even in the mass addition, there were two main parts which we discussed, the seismic mass and the added mass. And you see, once these masses are being tuned to the system, the entire system, the vibrating mass, can lead to the zero amplitude. So this is also one of the shielding feature through which we can say that even we can suppress the entire propagation path with this vibration suppression by adding these things. We discussed these things there. We also discussed about when we are designing the isolator or when we are designing the shock absorber, there is a straight methodology in that. And when we are talking about the shock absorber, there is a clear integration between the spring and the damper just to absorb the energy, to dissipate the energy and also to store the energy at the same time, so that we can control the oscillatory feature of vibration along with, you see here, whatever the energy is there, we can dissipate and transfer into the heat. So these passive features which is like directly added at the source or the receiver or during the propagation path, we discussed about that how the vibration can be straightway suppressed and the vibrating mass can be lead towards the zero amplitude of the excitation. But sometimes when we have this sophisticated system, we just want that we cannot directly add something to the system because sometimes it is not compatible, sometimes even the service condition or the environmental features or even you see whatever the design features are there of the system does not allow to directly act on such system, because now we need to generate some, because ultimately you see this is the force through which entire like the excitations are there because of the dynamic feature. So ultimately we just want that the system should even act against these frequencies by generating some cancellation forces. So this concept we are going to adopt in the next lectures, which is coming under the broader umbrella of the principles of active vibration control. So in this you see here we can say that ultimately our main aim in the vibration control is to reduce or modify the vibration level at the mechanical structure. So contrary to these passive methods which we discussed about the like the by putting damper or even the shock mounts in terms of the masses or like the acoustic packing when the insulators are being provided in terms of the propagation of the sound level or the various foams which were added in this active vibration control, the main thing is coming to superimpose the secondary noise or the vibration source on the primary source to obtain the minimum residual signal. So ultimately we are trying to adopt the two main sources in such a way that they will cancel each other. The primary source is the basic excitation force, the secondary source is nothing but the cancellation force generation, and then they are trying to balance so that we can have a minimum residual feature in the signal. So, the active vibration control is nothing but the active application of the force in an equal and opposite fashion to the force imposed by the excitation vibration. So, whatever the external excitation features are coming in the vibration, that can be balanced based on the force balance criteria. And with this application, a precise industrial process can be maintained not only on the platform, but also you see here on a specific part of the object. So, many precision industrial process cannot take place if the machinery is even affected by the vibration by adopting the passive vibration feature. So, we need to adopt the active and passive vibration control according to the system requirement and the application feature in the system itself. Like example, the production of semiconductor wafers, which require the machine to be used for say photolithography steps, and in this particular we just want the vibration free environment, or any like the sub micrometer features will be blurred. So, in that case you see here the active vibration control can straightway adopt there without putting any kind of like the feature in these semiconductor wafers. So, nowadays you see here the active vibration control has a greater application for reducing the vibration, like in helicopters, offering better comfort with the less weight than the traditional passive technology. So, sometimes you see here where we know that by adding something can create most of you see the inertia forces or some other things, then it is better to use the active vibration control there itself. Because generally previously we were, when we were thinking about the vibration control, we were only thinking from the spring mass and damper aspects. So, in this you see here like the traditional vibration, all either the shock absorber or the base isolation or the dampers or the we can say added masses, everything was considered in controlling the vibration wherever it is being there, heavy machinery to small sophisticated machines. So, we can say that there are various components which are directly involved in the active vibration control also, because it's not like that we can generate a negative force or the counterbalance force through the secondary source at the when the primary source is exciting the system. So, we need to see that what exactly the requirement is. So, if we are saying that a massive platform which is suspended by the several active drivers, we can say like the various coils, hydraulic, pneumatic or the piezoelectric or any other part, and through that the massive platform can also be whatever you see the excitations are there can be controlled by these things. And even we can put, when we are talking about the sensor or actuator, which is the integral part of the active vibration control, without which we cannot even think to gauge the amount of forces and to counterbalance that, the accelerometer is one of the important tasks in this. And even the accelerometer, either the single axial means uniaxial to triaxial accelerometers are effectively being used as the sensor feature, and then whatever the actuation is being required, the actuator whatever the force is being actuated through these actuators. So, we can use even the electronic amplifier which can amplifies and invert the signal from accelerometer to the required things. And in this you see here like we are going to use the PID controller sometimes you see here, which can give a better performance than any kind of simple inverter amplifier. So, you see here like there are various things which we are going to use in that. So, even for very large system, the pneumatic or hydraulic components can also provide a very good smooth or we can say steady state power requirement. So, that can also like the featured out when we are trying to design any kind of even the large or small vibration problems or like the system itself. So, active methods which can lead to the structure or the parametric modification of the vibration system using additional energy source, and that is why we are saying that like the additional energy source is a very active feature, that is why it is coming under the active vibration control methods. And this active system can generate the local forces related to the variable assigned to the other system where the point source is being there to generate the external source signals. So, using this active method, appropriate control external power sources can be supplied, or even the absorbed energy due to determined control algorithm can also be put there itself to counterbalance the generated forces. So, when the controller consists of the converter of any physical value, like the various dynamic features are there, either starting from the movement, means the displacement, the speed or acceleration. So, all three dynamic parameters when we are starting from displacement, velocity and acceleration, or even the force or pressure. So, when we are just trying that our controller should be converting the physical value, and then amplifier or actuator which is even being there as the additional feature and connected to the device. So, in actuator now, when we are talking about the actuator, it can be there as electrical feature, hydraulic feature, pneumatic features. So, this is what you see that like the straight connection, that first it should consist, you see, a converter through which we can convert the physical value, and then it should be amplified in such a way that we can absolutely gauge those things, and then the actuator when it is just going to the actuator in terms of. So, these are the three basic devices which are being used under that, and the actuator can produce a force, that is what the required force, that component towards the component, and the force which account the vibration suppression. And even it can also change the system parameter in the immediate effective active way. So, as a result, the vibration control problem may be considered as the problem of optimal control for the whole device. So, that is why you see here we need to optimize that, how with these you see the vibration problem along with all three connectors, right from the like the converter to amplifier to the actuator part. So, in general, when we are talking about this, and if we have means the active vibration control, and if we have the periodic vibration feature, then the control system can be adopted in such a way that it can like provide a better cancellation force than even when you have some aperiodic or some abrupt changes, abrupt vibration features. And we can rather refer this entire periodic system to the acceleration which is being generated and the counter acceleration which is being like provided by these actuators, or we can say the sensors like accelerometer. So, in general, if we are defining in a broader way about the active control system, then we have the input and output. The input may be single or multiple, or output may be like that, and then in between the input output we have the entire control element which we need to define the character, physical character or any other characteristics you see here of the control element. So, when we are talking about like the two main control loop particular, one we have the open loop in which, as we discussed, we have input variable, we have the controlled output, and this entire control system is being designed in the block as a control system. Even we can go for the closed loop, as we discussed already in one of the lecture. The closed loop is basically analyze the input and output signal and generate the error, because whatever the actual value and the desired value as an output is coming, we can rather compare the things, and then whatever the error is being generated or the created by the various nonlinear or any the actual feature of the system, that can be even amplified and feeded again to the system, and this iteration will be rounding up till the accuracy is the desired accuracy cannot be achieved. So, we need to like till that point you see here we need to run the entire system. So, if you see the B diagram of that, you can see that we have the input straightway going to the system, the controlled you see the output is coming, but even if we are not having the desired control output, again we can feed back to the system in which you see we have the comparator, the error is generated, and then again this error is fed to the system itself. So, this is you see here the two main strategy in the control system, one is the open loop, one is the closed loop, and if the input is stimulus, excitation or any like the command applied to the control system, typically we can say that like from an external energy source, whatever you see the type of source is, in order to produce the specified response from the control system, the output is the actual response which is being obtained by the system. So, as I discussed, sometimes we may have the desired output, sometimes we may not have the desired output, that is what we want in the controlled featured. So, input output can have many different forms like the physical variables or any we can say those abstract quantities which can be set as the reference or the set point or the desired value as an output control points are. And the purpose of the control system usually identifies the relation between, or certainly sometimes they are defining the relation between the output and input, and based on that you see here the accuracy is being defined of the system. And the output input system, as we discussed already, needs to be identify or even define the nature of system, that what kind of you see the entire physical nature of your input and output signal is, and accordingly the control system is being designed so that we can effectively control the output according to the desired nature. The control system may have more than one input, as I told you. So, sometimes we are talking about the single input single output CISO, sometimes we can talk about the multiple input and multiple output MIMO part, and accordingly if we have a single input single output, a better accuracy can be achieved by adopting a simple control system. But when we have the various parametric effect on the system and we want to control overall the vibration or anything you see here, then we need to design in such an optimum way of the entire control system so that we can effectively have the control on all these input parameters in the range where you see we have the desired, we are looking or we are seeking towards the desired output. So, this is a well defined problem which needs to be defined when we are designing the active control system, because ultimately we need to generate the forces through actuation and the sensing feature. So, example is we have an atmospheric electrical storm that may be like intermittently interface with the radio reception, and through that there is a clear unwanted output is being produces from the loudspeaker in form of the static part, and we need to cancel out this noise. So, certainly you see here we know that this unwanted output has to be filtered out from the which is coming from the loudspeaker. So, this noise which is coming as the output as an integral part of the total output, but sometimes for the purpose of simply identifying a system we can say that especially input producing undesirable output are not normally considered as the input output system. In the system description we need to add some kind of filter, maybe octave band filter, or we need to design the filter so that we can cancel out these things. So, now you see we can say that if we have say the electric switch which is being manufactured based on the control system, the controlling the flow of electricity is one of the input part in that, because we know that the electric switches there is an input and output feature is the electricity only. So, we can design the controlling system accordingly. So, by flipping the switch on or off may be considered as the input part, and this is when the input can be in one or two state of the electric switch can be, we can say that most rudimentary control system and a thermoelastically controlled heater or furnace automatically regulate the temperature of the room or enclosure in the control system when any kind of the noise or any kind of undesirable effects are coming. And the input of the system is we can say reference to the temperature, which usually we can say specified by setting the thermostat, and the output is the actual temperature for such systems of the room or any enclosure, and when the thermostat detects the output which is less than the input, we know that the furnace which is providing the heat we need to just we need to increase or we need to enhance the feature so that we can make a proper reference point right from the temperature enclosures. And then the furnace is automatically tuned off because we are setting up to that point, and when the temperature falls somewhat below to the reference temperature, the furnace is turned on. So, this is, you see, the automatic feature as we are talking about the automatic control on that when we are just going with this. So, this principle was first applied to the noise reduction system when the air ducts affecting as the wave guides, where the acoustic field is being simply to reduce the acoustic level in the structure when you have the free field noise or any complex geometry like generates the noise. And this was basically attempted to reduce the noise at the source by modifying the vibration behavior of the structure, means like when we are just putting the flat or uniform cross section, because from where you see this noise was generating. So, we can say that the active solution is a perfect supplement of the passive one, especially when we are talking about the low frequency domain, where passive systems are not as effective as compared to the active solution, because in the low frequency, in the passive solution, we are always adopting the spring. The spring is a perfect storage device, but if we want to effectively control the vibration exactly at the source, then the active this active concept of the vibration, in which you see the force is being superimposed on that, is a perfect solution as compared to the passive one. So, sometimes we are saying that this is the active vibroacoustic control, because you see here through that we have not only the control on the vibration feature of the system, but also whatever the spreading part of the acoustic level is there, that can also be controlled at the source. And when it is being applied to the structure, instead of creating an anti-noise wave, the principle consists of locating vibration sensor on the structure or in outside, like we can say the space, and actuator we can say capable. Whatever you see, we are saying that whether we are just putting inside or outside, this sensor feature is absolutely like sensing the vibrations, and actuator is capable of creating the vibration in the structure to achieve the minimum, like we can say objective function, or to reduce in an optimum way the vibration amplitude at the source itself using this vibration acoustic feature. And the sensor and the actuators are coupled in such a way that we can simply have whatever the sensing feature is coming out, simply like amplified and putting in the control to generate putting into the this actuator to generate the required force. And this is entire thing is which is being coupled with an electronic control system, either by analogic or digital control. This entire system is like calculating the signal strength particular, which is to be applied to the actuator in the real time to generate the force. So, this is, you see, the entire system in which you see here the actuator, the sensor, and when they are coupled to these electronic control system, either in the digital or analog form, it is capable of producing the anti whatever excitation force, like to balance out that part. So, we can say that that can be even attempted to reduce the vibration level of the structure even from the structure itself, not from the acoustic purpose, and through that we can provide, or we can improve rather, the comfort, we can increase the structural fatigue, or we can say the cyclic loading strength, or even sometimes through that we can even protect the sensitive equipment by suppressing the vibration. So, this is what you see, the fundamental area of active vibration control, which can be applied to even the micro vibrations and to active isolations as well. So, active control of the structure is nothing but a multidisciplinary field involving the various basic principles, right from the structural dynamics to fluid structural coupling, when the fluid induced vibration is there, and even you see the acoustic, or even whatever you see like in the material part, when we require some kind of specific features in that. So, we can see that in this, where there is a clear exciting like the primary acoustic source is there, and when it is being injected or imparted to the surface, you can see that we have a clear sensor in between the green part, and this sensor is being, like as we discussed already, is immediately sense that how much you see the acoustic level or the exciting feature of the vibration is in terms of displacement, velocity or acceleration. Accordingly, we can adopt the sensor. One of the basic features of the sensor is whatever the property which is to be sensed out, it can be straightway, we can say, physically put that part. Like if we want to sense the displacement, which is one of the basic dynamic parameter, the displacement probes, LVDT, strain gauges, these are the perfect devices which straightway can be used to sense out that. Or else if we are just looking to sense the vibration in terms of velocity, then the velocity probe can be adopted, even because you see here the velocity has a linear dependency not only on the amplitude of this excitation, but also the frequency feature. And when you see we are just going with the accelerometers, which are simply like measuring the acceleration feature of the vibrating mass, then we know that this accelerometer, which are simply like based on the two specific feature about the amplitude of the vibration and the frequency, whether we are measuring the low frequency, high frequency, because we know that the accelerometer, whatever the concept of the acceleration, it is depending the omega square. So even you see here, this is the nonlinear variation, the square variation is there of the frequency, which has the direct impact on the acceleration. So that is why you see like we can put, even for say we just want to actuate the sense the voltage difference, or even we just want to sense the temperature or the force, whatever it is you see here. And then you see here it is going to the control system, or we need to put like some kind of electronic control feature, maybe analogy or the digital part. And by analyzing the signal, the amount of force which is to be required to generate is being immediately like send it to the actuator. And these two actuators, which we are saying that the secondary source, are simply like generating the equal and opposite balance, we can say the force, and through which we are entirely balancing the structure, and it is leading to the excitation 0. So whether we are just talking about the primary acoustic source, or you see the residual noise, or even when we are talking about balancing of each other for this acoustic feature or for vibration features, the sensor and actuator coupled with the control system, automatic control system or electronic control system, provides a clear balancing part through which we can cancel out the noise or the vibration towards like the system itself. So there are various like the areas where the application of this active vibration control systems are, like the fixed wing aircraft, where it is not possible to adopt the spring mass and like the damper immediately at the source of vibration. Helicopters, in the recent time you see here all the active vibration control strategies are there. The launchers, satellite and the military system. So you can see that these all areas, they have a sophisticated like the machinery part, and in which you see here a sophisticated treatment is adopted instead of putting devices or any additional feature on the, we can say, the entire vibrating mass. So when we are talking about the active vibration control, it's not that you see all the time we can simply sense and like put the actuator as a mechanical device and then we are doing this. There is a clear, you see here, relation with this concept active vibration control, in which you see force needs to be generated against you see the excitation part. So the concept comes that you see why can't we feature this feature into the material itself, so that the material will like not only act as the passive feature, but also the objective, whatever you see like the part or this device, the objective itself meets with this material property with this manufacturing object. So every feedback system, when we are talking about, they have like essentially various components, like we can say hardware computing control input, or even you see various strategies are there in which the sensor is providing the entire feedback and the actuator is simply carrying out whatever the requirement is there in the like whatever the dynamic feature of the system is. So we can say that we are trying to focus on the sensor, actuator and automatic control part in this, And more specifically, if we are saying that when we are talking about the sensing part, the first thing is coming, what is the material property in that. So again you see here, once you sense accurately any parameter, as I told you, whether the three basic dynamic parameter like the displacement, the velocity or acceleration, or even the force, temperature or anything, when material can act as a sensor and sense those features, and accordingly you see the actuation is being induced by the material itself against that, it is a perfect way you see here through which we can apply the concept of this active vibration control feature. So AVCs, when we are talking about active vibration control technique, we need to first focus on the sensing feature outside or the material itself. And there are various very well known, like we can say the traditional actuating components are there, like the electromagnetic devices, through which you see here whatever the electric features are coming and concept with the electro and magnetic field, we can straightway actuate the system. The pneumatic actuators are there, where we need to use the fluid or the air as you see the actuator feature. The rotating and the linear motors, the servo motors and various other things are there, which can be immediately act as the actuator part, because ultimately we need to utilize these features against the excitation feature. So when we are talking about these kind of systems, we can say when the material or these components are providing the anti the exciting force, we can say the engineering material which can do that is coming under the intelligent material or the smart material, because ultimately you see here these materials are doing all these actions, sensing to actuation by their own characteristics, the inherent feature, the inherent property. So they are acting as you see in the smart way by sensing and actuating automatically, and whatever the amount of force which is to be required to dampen out the vibration or the noise, they can do by their own featured. So you see here, not only they have this smartness of this kind of sensing and actuating feature, but also you see here they have very lightweight, and more importantly that can be even seamlessly just integrated along with the structured part. It is not that you see here we need to put and add something here there itself, they are straightway you see here the most compatible feature of the structure when we are adopting this smart materials. Like we see when we are talking about say a composite aeroelastic wing, which is equipped with the thin piezoelectric wafers, and its most compatible feature when you are simply putting a thin the piezoelectric wafers along with the aeroelastic wing, and when we are casting directly to the structure, it can straightway suppress the undesirable vibration without even adding any kind of the seismic or the added mass, or even without changing the shape of the entire wing, or even without adding any kind of damper or these spring elements. So the advanced materials like the magnetorheological fluid, the electrorheological fluid can also be add some special properties which we are saying that unprecedented properties to the existing component, so that you see here we can create a good amount of damping feature from the material itself. And even right from the basic car, this the automatic vehicles from the cars to like railway vehicles and the aircraft parts, this MR fluids, the magnetorheological, because you see here the fluid itself has the two main property, the rheological and the magnetorial featured, when you see the entire suppression of the vibration is being there because of these damping part. So this damping property is being enhanced with the using of this magneto or electrorheological fluid. And we know that when we can sense those things in terms of the displacement, or in terms of the velocity or acceleration by the sensor, that can be even actuated accordingly. So when we are talking about the sensing feature, the smart material is always just use these things, like you see as example the piezoelectric material. The robust and the low cost high displacement actuator, generally we are saying HDA, just made the pre-stressed this polymetric material and the piezoelectric ceramics is an excellent example of these advanced materials features. They can be act as a smart material towards this vibration suppression. And the aim of like here, this entire part is just to give a cutting edge material and their use in vibration control straightway, because through that we need not to add any special, we can say, the sensor or actuator part. So actuator, like you see, as we discussed about the electromagnetic, or you see the light motors or pneumatic devices and others, will not you see just putting here, because ultimately our main focus is to go towards the smart material part. So you see, we know that whatever the reciprocal physical effects which are being coming out from these materials can be added as the actuating elements and the sensor configuration feature there itself. So just you see, in case of actuators, like we discussed, the feedback sensing system is absolutely existing there inside the microstructure of the smart material. And some of these are, we can say, like the accelerometers, the strain sensors, they, or even you see which is simply based on the resistant wires or any more advanced device, can be straightway put with the using of, say, the laser vibrometers for the nano parts and everything you see here, that can be straightway used. So there are several engineering materials which are being available nowadays, and they are providing the desirable impacts, act as a active vibration control part. So when we are saying that they are the smart materials, that means to see here they are they have the smart sensing and actuation features towards that. And when we are just when we are thinking from the structural point of view, the behavior of classical material can also be sufficiently described by their elastic constants, which are simply relating the elastic feature between the force deformation or the stress strain, and along with what are the thermal constant rates are there. That means you see what exactly the relation with the creeping effect when you see all these actions are being happening along with the strain. So the smart material can coupled also with the existing material, and then can also provide the field like the electric charge, the strain, or the magnetic field, or the temperature, chemical, or any lighting part. So these are the key parameters which are being looking at in these smart materials. First the electric charge, second even the magnetic feature, even the strain part, the temperature variation, and the chemical and the lighting effect with the microstructure. And this coupling is also obvious between the constitutive equations describing the behavior of these smart materials. And the most common smart materials which are being used in the active structure are the piezoelectric ones, the shape memory alloys, the magneto and electro restrictive materials, the semi-smart like the magneto, the semi-smart materials are there, in which we have the magneto and electro rheological part, the rheological fluids, the piezoelectric materials, in which you see here there is a clear coupling in one direction to electrochemical materials. And of course you see here we can say that in the piezoelectric part, which direction is being dominating, we can create according to these fields in the piezo sensing and actuating part. So you see, we will discuss about in detail in these the lecture series about the shape memory, piezoelectric alloys, the piezoelectric feature, the shape memory alloy and their effects, and what the various other smart materials. So we know that you see these things are very interesting, that how the superimposing nature of these materials is creating you see in terms of the actuations and the sensing part. So there is again you see we are going to discuss about the effect of these various parametric feature on these smart material. So under the broad category of smart materials, we can say that there are significantly change in the control fashion by putting these smart materials such as the stress. We just want to control the stress, say the temperature, the moisture, the pH value, the electric and magnetic fields. They are real, we can say, the external stimuli. And there are number of the types of these smart materials are there in that, like the piezoelectric materials. And these materials are nothing but, you see, we are going to take the detailed feature of that, but right now I am just going to categorize these things. These materials that are simply producing the voltage when the load or the stress is being applied to the system. And since like this effect also applies in the reverse manner, a voltage across the sample, across the entire specimen, will produce the strain or the stress like within the sample, and you see like the counterbalancing feature is being there because of the piezo nature. Suitably designed structure made from these material can be like we can say like can be straightway put on the bending part, or we can say it can be even extended. It can be extend, you see in the pulling part, it can be even compress the part when the voltage being applied to the system. Second is the shape memory alloy and the polymers, which are being simply made with the large deformation, and you see we can say that they can be induced and recovered through the temperature changes or the stress changing when the pseudo elasticity is being commonly featured with the shape memory alloy. And we know that you see like when we are changing these things, even there is a clear change at the microstructure, right from you see like the basic structure to the even Martensite phase of the structure under the large deformation. We are going to discuss about how these alloys are being framed and how we can use these even at the real material level. Then we have the magnetostrictive materials which can exhibit the change in shape under the influence of magnetic field, and also can exhibit the change in their magnetized properties under the influence of these mechanical stresses, and through that the sensing and the actuation features can be coupled together with these changes of that. Then we have magnetic shape memory alloys. These are the material that are changing the shape with respect to the significant change of the magnetic field. So that can also have a clear application in various devices. And then we have the pH sensitive polymers, which are simply swell or collapse when the pH of the surrounding media is changing, and immediately gives the sensing that you see what exactly the changes are there in the moisture or the pH values outside field. Even we have the temperature sensing feature like the temperature responsive polymers, which can immediately sense any even like the changes at even some digital change in the temperatures can be immediately sensed out. We have holochromic materials, and in that you see here whenever there is a change in the color, immediately you see here there is a change in the acidity part of this material, and immediately it will sensed out. So there are you see like various applications are there towards you see the paint, in which you see there is a change in the color to indicate the corrosion feature where the acidic environment is there at outside can be immediately sensed out with the using of these sensor. So chromogenic you see systems in which you see when we are knowing that there is a change in the color and can be immediately respond to the system, and the corresponding changes are being occurred and can be calculated with the electrical, optical or any thermal changes in the material itself. So these materials are clearly showing the voltage drop when there is a change in the like we can say the color, and when you see when even the temperature or anything is being changed, the like we can say the LCD devices in which the liquid crystal displays are there, the we can say the thermochromic material can immediately find out that what the changes are there in the temperature or the we can say the photochromatic materials, and through that we can say immediately we can sense out. So these are the smart materials in which you see the clear changes there according to the application itself. So you see various other examples are there, like you see we can use the ferrofluid, we can use like the photochemical or photomechanical materials through which we can simply change whatever the shape changes are there with the light. The self-heating materials are there in which you see there is a clear property of repairing the damage due to any materials fatigue or any kind of you see changes are there in their temperature feature. And even we have the dielectric elastomers in which you see we have not only you see the elastic features in the smart material itself, but they can also you see here produce the large strain because of the dielectric part in that, and they can straightway influence entire electric field with the using of this concept. So these are you see the smart sensing and devices actuators in which you see there is a clear coupling between, you see, the like the sensing and actuating feature, and then can produce the rest, whatever the restrictive features against the excitation force. So in this chapter, you see here we discuss about the basic concept of active vibration control, and what is the requirement of this active vibration control is also being discussed. And then in the later stage we discussed about that, like how we can produce this active vibration control, because sometimes when we are looking that the basic devices are the sensing, actuations and the we can say electronic coupled system, but all the time, you see, this is not feasible to do that. So we need to we need to use the ingredient property of the material through which we can sense the variety of the parameters, and the same time, you see here the material property itself, you see, excite against that in which the actuation features are being there. Okay, and in the next lecture now we are going to discuss about, we will take, you see, the individual material about the piezoelectric or the shape memory alloy, and we will try to analyze the active vibration controls with the using of these materials. Thank you.